Hello everyone, this is INE Foundation Lab 3 and Section 6.6 MPLS backup. Okay, this section is about OSPF Sham link. Let's review OSPF Sham link concept and I will come back and configure this section. Okay, OSPF root preference hierarchy. OSPF classifies linear prefixes into four main types and always picks the best route by evaluating typeface, then cost, and finally tiebreakers such as author ID. Okay, OSPF chooses best route by selecting its best route types or the best LSA. Route type it is like uh, OSPF routes inside a short P route OSPF. Its first is in OSPF inter area always is preferred over inter area routes. These are OSPF routes. We have inter-area route, which is shown by O. We have inter-area route or ORA, extra type 1 route OE1, and extra type 2 route OE2. These are OSPF routes in short route OSPF. In OSPF, inter-area routes are always preferred over inter-area, and extra type 1 is always preferred over extra type 2. These are OSPF good hierarchy, good preference hierarchy. Inter-area routes are learned from hotel LSA type 1 or network LSA type 2 within the same area. And inter-area routes are advertised by an area border router or ABR via summary LSA type 3 or type 4, carrying reachability from one area into another. And extra type 1 or OE1 is learned via type 5 LSA from ASPR. And it cost equals external cost plus internal cost to ASPR. And extra type 2 also learned via type 5 LSA and its cost is equals to external cost only. Okay, this is path preference. Preference or in path or spare path. Or spare always prefers an inter-area path over inter-area path, regardless of its cost. Interior path is always preferred over interior and extra top 1 and extra top 2, like auto SPF routes. This is OSPF path. And why interior beats interior? This is the reason. Interior paths are built from interior paths are built from the local LSTP and they reflect the most detailed view of topology without summarization. And interior routes are summaries. Even if the advertised metric appears low, they may hide topology changes or barcodes across the backbone. And this is how OSPF metric is calculated in different areas. In each area, OSPF calculates its cost like this formula. It is sum of link cost within the area. In inter-area, it is cost metric is calculated by this formula. This is cost to ABR plus some arithmetic in top 3 or top 4, let's say, and extra top 1 is internal cost to ABR plus external cost, and extra top 2 it is extra cost only. This is metric calculation in different OSPF areas. Okay, this is how OSPF would prefer is working. And keep in mind, inter-area is always preferred over inter-area and extra top 1 and extra top 2. Okay, and OSPF Shami. This is OSPF Shami concept. What is OSPF Shami? OSPF Shami is a mechanism used in MPLS related VPN environment to ensure optimal inter-area routing between customer edge or CE routers when these routers share a backdoor or direct link. Okay, let's show this image. Just we can understand what is why we use OSPF sharing. This is P1, P2, and this is C1 and C2. We have backdoor link for C1 and C2, and this is inter area, and this is always preferred over inter area because link between backdoor is interior, and this link is always preferred. And what OSPF Samlink is doing, and the job of OSPF Samlink is to ensure optimal inter area routing between customer edge routers when those routes share a backdoor directly. This is like this image I show. I will show. I will explain this a little more later. This is by default, MPLS VPN routes are treated as inter-area image. It is always treated as inter-area. So OSPF will prefer any available inter-path. We prefer any available inter-area path, even if that path is suboptimal. It will always prefer inter-area path. OSPF inter-area path. OSPF will prefer this backdoor link instead of OSPF link. And OSPF rank routes by area type. I explained it before, later before. You need to only prefer interior and external. And why we need OSPF sharing? As I explained before, OSPF prefers interior routes over interior. In MPLS VPN, routes landed via the backbone. And this is backdoor, and this is backbone. Let's edit this one. Okay. This is our backdoor, and this is our backbone. Backdoor and backbone. This is backbone, and this is backdoor. Okay. backdoor listening. Okay. OSPF prefers inter, interior routes over interior routes. In MPLS VPN, routes lined via the backbone are seen as interior, while backdoor links between three routers are interior. This causes traffic to prevent the backdoor link, even if it's less optimal. And it will choose this backdoor link. We choose this link, even if it is less optimal. For this reason, we have to use Sham link. We have to Sham link between PE. Yeah, we have to create a Sham link between PE and PE1 and PE2. This is our Sham link. Sham link. And what the Sham link does, it creates a logical point-to-point link between PE routers. The link allows OSPF LSL to be plotted across the MPLS backbone, and routes landed via the backbone are then treated as inter-area, overriding the default behavior. This is the job of OSPF channeling MPLS VPN. And to configure it is so easy. Under hotel OSPF configuration, hotel OSPF process ID, specify area number, for example 0 or what other number. Then I type sham-link and specify the first P loopback, the first loopback of P1 and loopback of P2. I can also specify cost here. This is mandatory. This is OSPF family configuration command. And the loopback must be reachable via VPN and addressed into BGP. Important to understand. And the BGP address family via. Okay, now let's this. This is OSPF sharing concept, and this is how we use and why we use OSPF sharing in MPLS VPN. And let's conclude this section. Okay. Configure network so that switch 1 and switch 2 use the MPLS network to reach each other loopback 0. You have to configure this network so that switch 1 and switch 2 use MPLS network to reach each other loopback 0. Okay, let's verify the current view of switch 1 and switch 2. If I trace put my switch 2 loopback to switch 2 loopback. Okay, it is using directly connected interface. Oh, this is using port channel interface. Switch one to this interface. Okay, let's explain what we have here. R6 is IP, 5 is IP, switch 1 is our customer edge, switch 2 is our customer edge. here. This is what our channel 12 is our like here. This is our backdoor link. This is our backdoor link. Okay. If I do hardcore root, OSPF, it is using OSPF beside of 100 and it's using your for channel. Let's show down interface. I'm using area, this area number. I put on area 5, 6, 21, 21, 22. Let's verify on IP on 5. So IP root. What is inside VIF? So VIF. So IP root. And this is on OSPF 1 and this is interior. This is this one. 1.225. This is this interface. Yeah, okay, at this moment, switch one is using backdoor link. This is using a backdoor link. Then so without we have to configure. So it's using MPLS instead of backdoor. Okay, let's configure this. Okay. Configure the network so that switch one and switch to use the MPLS network instead of backdoor link or loopback 0. Ensure that the port channel interface between switch one and switch 2 is used if the MPLS network fails. This is our backdoor. Mm, It uses backdoor. If it uses backdoor link, and switch one and switch to loopback 0 network should be seen as internal or routes within OSPF and you are allowed to create two new interfaces to accomplish this task. Okay. Yeah, I will create two new loopbacks on P routers. One are 6 and the other one are 5. Then then assign those loopback into VRF. Let's wait and configure this part. P RP show VRF. Let's config P interface loopback 1. VRF forwarding VPN A IP address 55555555 then 255 then 255. Same on another P show VRF config interface loopback 1 VRF forwarding VPN A IP address 66, 66, 66, 66, click on I created two new loopbacks and authenticated back into VIF. Let's verify to show web my loopback to show VIF. My loopback is here. Then I will add this loopback into our P. P and whatever to show run pipe section with a PGP. Mm, this here. Add this one VIF on the rotate PGP this number. Then I'm going to install others family before we have pin A and advertise my loopbacks. Then another P, do shutdown, 5 section, rotate PGP. On network, 66, 66, 66, 66, mask. Okay. Between my I have to create Sham between my PUs, between R5 and R6. Okay, let's do show down 5 section. Go to OSPF. Yeah, this is my OSPF. You can OSPF 100. I will go this under this OSPF process. I will create sharing between IPs. Let's verify to show down 5 section with the OSPF. Yeah, hotel basis on one. Okay. Okay, sharing guys area. My area number is let's verify switch one. This is area 562122. Family. My source is 555. Source with back. And second P number is this one. Okay, here. And another hotel. Area. Sham link. 66. 5555. Okay, my Sham link is created. And switch master loop back network should be as internal. And you are created to me. Okay. Then I have to change my OSPF cards on my poker interfaces. And let's verify this. It is not still using. It's still using backdoor. The stage one is still using backdoors instead of backbone. I have to change the OSPF cost on poker interfaces. PT, interface brief, interface for channel, IPOSPF class S7. Someone here for interface brief, IPOSPF class. And now let's verify. Okay, now switch power is using backbone instead of backdoor to reach switch 2. This is always with jambling and cost changing cost on what channel is working. Okay, now to show IP root. This is enter area. And situation pattern should be seen as internal or interior root. If show IP root OSPF, This is all integers. Okay, this was our last section in MPLS VPN, and I hope you have enjoyed this video and thank you for viewing.